I've been investigating ways in which we could build common libraries to accomplish things on the web that you might need to share between many sites. And what naturally comes up is you don't want to have to pay the download cost as you go site to site using the same library. And this is true for a lot of existing libraries as well. So there's been a few proposals around this idea. One of them is web shared libraries. I more recently discovered there's also an SRI cache proposal with a very similar concept. So basically, the idea is if we look at the loading costs of sites on the web, we're looking at about 2 megabytes to load a standard website, and about 1/3 of that is script resources. But there's other resources that we could help as well, like font resources that are shared. The point being, I think there's a fair bit of potential to reduce the average page load size if we could identify common resources that you're likely to have on multiple sites. So one of the questions that usually comes up is, like, why can't we just do this with caching, right? And without double-keyed caching, we can in a way. So imagine a.com includes a library from some CDN. And so it stores it in the cache. And then you visit b.com, which uses the same library. And it comes from the cache. Everything's happy. The problem is you've got this dependency on an external server. So imagine that cdn.com isn't able to keep up with every site, including it as a common resource. You now have an error visiting your site, and users can't get to it. And this will persist on every single site that tries to make use of that resource. And another one that I already alluded to earlier is we are looking into double-keyed caching. And I believe Safari already does this, where your cache is basically bucketed by the top-level domain. So the cache hit from a.com is not actually shared with b.com, which has to separately request the resource. This means that even if you had this scenario, the same resource from the same URL shared across hundreds of domains, you would have to separately download it for each domain. We might be able to deduplicate the resource on disk, but you've still paid the loading cost of this resource. So the web shared libraries proposal, which some, or I should say brainstorming, which some Mozilla engineers put together, is we've got an integrity checksum, which can be used to verify the resource you download is legitimately the resource that you thought you were downloading. So we can use this checksum essentially as a cache key instead of the URL from which you're fetching the resource. And then there's also this concept of a shared channel, which gives you the opportunity to communicate the concept of like multiple releases of the same library. So using this shared channel URL, you can have a public key that signs releases. You can have a canonical release URL, which you can always go to fetch the library as some sort of a fallback, or maybe you update in the background, that sort of thing. So if we go back to the earlier examples, you have a.com is loading some script. In this case, it's loading from its own site, but it specifies the integrity. So when that's cached, we save it as a cache for this integrity checksum. And then visiting b.com, b.com is loading it from the CDN, a different place, doesn't matter. The integrity matches, and we're able to serve that resource from cache. The shared channel is a bit more complicated, so I thought I'd spell this out slowly on a slide. So for a.com, you load your library. It's just specifying a shared channel. So the first thing we do is we fetch the resource. We've never seen this lib.com channel before. So we fetch the resource, we calculate the integrity checksum, and we send it back to the site. But then we also do this background lookup on the shared channel to say, is this a valid resource for this shared channel? And it will look up the public key, verify that the resource is signed with that shared channel, and after all of that, make it available for other sites to use. This means that you can't hijack what the resource is without the private signing key for lib.com in this case. So then b.com is specifying the same thing. When it goes to fetch the resource, it also doesn't know what integrity checksum to expect. So it does a head request to the resource on cdn.com to say, hey, what version is being served by cdn.com? When that comes back, we get the checksum match, and we verify it from cache. And we know to do the head request because we know we have a saved resource for lib.com in the cache. So high level, this lets you use the same resource across multiple sites, served from your standard serving URL, not depending on an external domain or anything like that. So I did a crawl of the top 10K pages from the Alexa top 10K to try to estimate what the impact of this could be. As you can imagine, right now, without this resource or this incentive to share libraries, it's not going to be as large as the potential opportunity if we implemented this. But even as it is, we could download the top 100 libraries, save them into cache. It would take 1.9 megabytes. And if you were to visit every domain, you would save 1.2 gigabytes across the top 10K sites. And the top 500 libraries, only 10.7 megs. And that saves 7.6% of all the bandwidth, or 1.9 gigs, across all of the resources. I'll just, oh, sorry. Right. So this is why I have the percentages as well. If you were to visit some selection among the top 10K, I assume that you would hit somewhere around this percentage of cache savings. But obviously, we can do more precise math. I should hand a mic out. Yeah, so as I was mentioning earlier, the long term is we would create this incentive to share common resources. So as you are building your site, common versions of common libraries would usually just be in the user's cache because they had already seen them. The goal would be to promote a common set of core libraries that you share across domains. Just like organically, we're hoping that developers would arrive on, these are the set of libraries that would be really useful to share. Unlike browser built-in features, you can quickly update libraries, just specify a new version. And in order to make this work with bundlers, we're hoping that there would be enough of an incentive to unbundle popular libraries, because you could potentially get this shared cache hit, that we could build some sort of logic into a bundler to unbundle these resources that might be popular enough.
How would that work with HTTP2?
It doesn't change the request model. So I guess I'm not sure I understand.
So in HTTP2, when you request a resource, you might get back more resources than what you asked for.
Yeah, so you could preemptively push resources you didn't think the client would have, but I guess you'd want to wait for some of these ones that might potentially be shared, because you don't know whether the user is going to need them.
So it would have to be a deliberate design of the request model.
Well, whether you push the resource is part of the server, right? Like, yeah, so you would have to design for this case on your site. So I wanted to raise some of the privacy concerns around this, so that we can talk about this a bit more. Imagine you visit a.com and it loads the library, or sorry, it specifies the integrity checksum. But if you try to fetch that resource from a.com, it's just a 404 or whatever, so it will not actually cache it. This effectively lets a.com say, do you have this library? Which reveals, have you been to other sites that use this library? Similarly, you could imagine some sort of cooperative tracking where a.com wants to share some ID with access from b.com. So they construct a set of libraries representing the user ID bits and load the ones which correspond to the ones and check on the other site which ones have been cached. So yeah, obviously we want to avoid this. Sorry. There's a second mic. Let me
turn it on. Yeah, I just sort of wanted to call out that I think the thing I really like about these examples is that there's a lot of discussion in this space around timing attacks, which is sort of often what it is with, like, that's one of the reasons we're doing the first-party keying. But I think this shows that when you get into the content addressable space, it's not even timing attacks anymore, right? Because there's no timing attacks in either of these cases, because as long as you're allowing developers to specify like the hash of the thing, but potentially never fetching it, then you don't actually have to host it, and people can deterministically figure out if it was loaded from cache or not.
Yeah, exactly. So this is why I think we have to be really careful about what is possible to infer from a cache hit. So one of the ideas, and this one is in the web shared libraries TPAC discussion, is that you just always fetch the first time you see a library from a new domain. So this has the benefit that, like, you can't really tell if subsequent hits are from your cache or not, with a caveat that this also means you have to evict it at the same time as other resources. So this really doesn't have any benefit, I don't think, over regular cache, because it has to disappear from your cache at the same time, or else you can tell the difference between a non-shared resource and a shared resource. Another option would be we always prefetch a known list. This could be built organically, like popular requested libraries. And this means that the presence of a library doesn't say anything about the user's navigation history. We don't even necessarily have to prefetch the resources up front. It could just lazily fetch these resources. And so when you get a cache hit, it may have been prefetched by the browser. It may have been the user navigating to another site, but you don't really have any signal either way. The downside is, like, you're fetching resources that you may never use. Yeah, I guess I removed one of the cons and didn't update the slide. You don't have to download everything right away. But as I noted earlier, the size of all of these resources isn't that large. If we're talking like top 500, 10 megabytes of cache is probably doable for most devices. And we could even adjust this for, you know, number of megabytes you're willing to dedicate towards a shared cache. Another option is the same sort of mechanism where we use a determined list of, like, how often our library is fetched. We don't prefetch them, but we only share ones from this list, with the hope that any library that is used by at least like N% of domains on the web doesn't really give much away about the user if it's present in cache. This is still susceptible to some leaks in that it does identify categories of sites. So you could imagine, like, a gaming library a user wouldn't have in their cache if they weren't a gamer, and they would if they were. The other thing that might happen in this case is a cache miss could become a signal if it was an extremely unlikely library for a user to have. If that happened, though, we could create false negatives. Similarly, we could create false positives by prefetching some of these libraries. I think a lot of this prefetching depends on having canonical URLs, which is going to require some bootstrapping of the ecosystem, but it's possible.
Can you go back real quick? So two comments. One is I think something like this will enable us to do sharing of AI models as well, right? And that'll be really nice because they can be huge. And if everyone wants to do this thing, but no one's willing to upload a 200 megabyte model, if you do it once, then maybe that's not so bad. On this particular case, another con here is exactly what you talked about before, where if you had 32 bits of information from 32 libraries and everyone was using those same 32, then they would be considered common libraries, and they would get around this. And you could still identify a user uniquely.
Not if the places you might get the library are sufficiently diverse. So you couldn't tell on the other end whether it had come from your cooperative endpoint or some other domain, right?
But could you not just use like a.com/1, a.com/2, and just 32 of those, and everyone use those same?
But the only way these become popular is if they're requested from a bunch of other domains.
Right. They're all sharing identity, and they're all loading these same 32 things.
I think I get what you're saying. Like if you were to do this from multiple domains, request a.com/1 through 32,
yeah.
Only one developer could do this. If more than one started, then they would trample each other's bits. But hypothetically, yeah. That's an advantage for the earlier approach of prefetching. There's a question behind you.
Some approach to kind of reverse the entire thing was foreign fetch. And I just dug up the GitHub issue again, and there it says it was closed. Let me just read that out loud. Due to problems with double keying, unclear trial results, and unclear use cases, we are going to remove foreign fetch from the spec and fetch spec. Can you, do you have any background on the unclear trial results that they made in or had in 2017?
I don't have any background on that.
Anyone in the room, maybe? So foreign fetch was a proposal from the service worker side to just let commonly used resources like Font Awesome sort of install a service worker on their behalf. So you would visit a.com, that was to include Font Awesome font, and then Font Awesome would install a service worker on Font Awesome's behalf without even a.com doing anything. So they could kind of extend their cache time by installing the service worker.
So I'm not sure quite sure. I can't answer the unclear origin trial results, but I think that it seems like part of this proposal is trying to work around the privacy implications of having that kind of cross origin caching, which was the concern with foreign fetch, is that it because it didn't control for it didn't put the user agent in control of how resources are cached and how we could do various mitigations for that kind of cross origin communication. It wouldn't work.
At the expense of having to go through popular libraries.
Right. Right, but I think the key property of this is that by making it for popular libraries only, it mitigates the privacy concerns that this kind of caching causes.
Yeah, as an interesting data point, on the top 10K, Font Awesome was fetched from 477 different URLs, so different sites serving it. That's one case where you need some kind of content addressable keying to share that resource.
Do you have a sense for the price you have to pay for the round trips for the head request? How much that eats up any performance benefits you get from caching, particularly if you're talking about unbundling it from a bundled resource?
So you can avoid the head request if you specify the integrity you're expecting in the HTML, but like that head request is just an easy path for if you're pointing at a CDN where you don't know what version they're serving, but you want to rely on their server. I think there are things we could do to avoid it. For example, that resource shouldn't be changing very often. So no, you still have to do the request. There are probably things we could do, but like if you were allowed to upgrade the library version, you could just fetch the latest from the channel, but that's going to be hard on developers.
Yeah, and just to add to that, I think that the head request thing was only part of the sort of more complicated WSL proposal. And sort of just to give context on that, like that was sort of like a brainstorming attempt from some Mozilla and other folks last year of like how you would build like a fully decentralized system. But like in the end, we still ran into the same privacy leak. So I think we're kind of putting all that aside for now. And I think for us, like the primary question is like, can we satisfactorily solve the privacy leak and see what that solution looks like and figure out if any of these other capabilities and affordances of the system would still be necessary or make sense.
Yeah, and I think implementing something will give us a lot of good information about how we could improve it.
Do you have a sense in the field? I know Josh mentioned during his talk earlier about the double keyed cache that Chrome doesn't see a lot of duplication of resources in reality in the cache. Do you have any idea from Mozilla's side? Is that something you have visibility into?
I don't have visibility into Mozilla's insights on how often resources are identical, but perhaps.
I don't have visibility either, but I think one key point is that like a lot of the discussions around the double keying are about things being fetched from the same origin. But what often happens is that it's the same resource as far as the content goes, but it's just hosted from multiple origins.
So I can speak for the Chrome side of it. We do actually periodically look at, this is anecdotal only, one's own cache and just trying to MD5 sum everything in there. So it's an integrity sort of unique, similar thing, and trying to see how much duplicate is in the cache of a single cache. We have not done it since double keying, so it should increase since then. But before double keying, even though they were in fact on different sites, the people use their own version of jQuery. No one's using the same version of anything except AMP because they have to.
So like I did do a crawl of the top 10K and found a few jQuery versions were quite popular. Like 3.3.1 was very popular. The most popular, but
I guess the difference is between the top 10K versus like the sites like an individual user actually goes to.
Yeah. Yeah.
So I'm glad to see this discussion actually happening. I have in the past suggested almost exactly this in a number of venues. And there have been lots of things thrown back about it. And actually, I do think some of them are valid. So like I'll bring them up. One of them is why are there so many CDNs and so many ways to serve jQuery? And why is our best advice still, you should probably package it up? And like one of the reasons is because it's completely unpredictable, right? Like if developers can't predict how it will work, it's usually better to include it in your bundle, right? And so I don't know that this makes it less unpredictable. So I'm just wondering, like, can we actually convince developers to do it? Is there any data to suggest that it will work differently this time? Again, I'm pro, but this has been raised in the past, and I don't think it's should be taken lightly. There's a point here.
So I mean, hypothetically, if the list of things that would be in this cache are well known, bundlers could take advantage of that and specifically unbundle the things which would be in the list. That doesn't necessarily say whether they are cached on the first visit, although the best privacy preserving option we have is to, at least lazily prefetch all of these resources that we think should be in that list. So the odds are pretty good that by the time someone gets to your site, they will have it cached. Obviously, this list will change over time, and yeah.
I was just going to add a little bit more on that, which is I think there is kind of a concern around the performance benefits here. I think from like a byte consumption perspective, like this is a pretty strong win. But just as far as kind of just the latency concerns, it may, I think basically there might be some more investigation that we could do. In the past, previous attempts to kind of evaluate the performance benefits of unbundling, like go full HTTP2, server push, just do like the best optimized way of unbundling. Still, like the just overhead of Chromium and Blink making network requests, making 200 network requests instead of one for Lodash, as an example, were pretty significant. So I think like the current solution is you got to make a balance as far as how unbundled you are. It's kind of like anyways, so there's a balance there. One super practical question that I just don't know the answer to is, so the integrity hash is all the sub-resource integrity, I imagine. And is that, I just don't know if that's currently supported with imports, JavaScript imports and dynamic import. So I was just curious about that.
I don't believe it is. We would have to extend.
You'd need something like import maps to like have an out of band way of supplying it.
Yeah, import maps tackle that problem.
It is intended to. I don't think it does right now.
Okay. That's fine.
It's
yeah.
yeah. I wanted to talk about the first thing you said though. Actually, is the bundling thing. Is after having spent years on our end, Mozilla having spent years on this, like it's been like 20 years people have been talking about like, can we cache libraries across origins effectively with integrity hashes and whatever. I have come to the conclusion that if there's anything we can ship that provides any value, we should start there and then go from that. And in particular, when we look at a lot of modern sites, like freshly built sites, there's a small number of very large libraries that a lot of them use. And if all we did was get those very large libraries to be shared, it would be a huge win. So Moment.js is like 200 something kilobytes and is often included like multiple times due to people's build systems and stuff. Shaka Player is used widely and is enormous. And certain fonts. Font Awesome was mentioned. If all we did was got those three things to be shared, that would be a pretty big win, and it would be an incremental step where we could learn what the next step is to get to the like bigger vision of a decentralized system.
Question.
So I just got here for the summary, so I will likely, you likely talked about it, but how can we make sure that who decides what gets in and what doesn't, and how can we make sure that we don't, make kings and, decide which libraries will or will not be used on the web?
So it's already true today that your cache, like your browsing history decides what gets into your cache. We would be basically creating like a unified cache of the web that would be ever rolling forward with whatever is the popular set of libraries and resources of the current like time. It's not us choosing a thing, right? Like we're going to build this organically with crawling or with real user stats.
Yes, but we're giving real performance advantages to current incumbents versus the newcomer. But I guess that's also true for cross-origin caching right now.
This is the thing that this is why I opened with, we've been trying to do this for 20 years, is everything has this problem. So the question is, what's the alternative? Is the alternative we still just ship 500 kilobytes of Moment and Shaka Player across the wire on a large percentage of sites? That seems worse to me. So I would love better suggestions.
I love Ojan's suggestion of like, let's try to start with something incremental that we can try to show has real value. There's going to be some tough trade-offs there. Like if we can save a tiny bit of FCP by incurring an extra 10 megabytes of transfer on every device, would we make that trade-off? I don't know. Seems tricky. One of the things I'm most worried about though, in trying to like the specific proposal of let's pick libraries that are shared already, but tend to be served from the individual. I think that's what you were saying, right? Like they tend to not be served from a common place. They're each served individually. There's a tough trade-off there for site authors that, Rob, you were talking about how there'd be this huge performance advantage. I'm a little skeptical of how huge it would be, but if you ask site authors to make a trade-off between performance advantage and the predictability advantage of controlling their own release cycle of updates, of knowing when their site might change because the script they depend on has changed versions, I suspect they would almost always choose the predictability choice over the performance choice.
This version using content checksums is serving you the version that you're hosting wherever we are pointing to.
So your URL points to your own server. Your URL points to your own server still. The integrity hash just means it pulls out of a shared cache. So it doesn't have the predictability problem, actually.
Okay, so but then to make it so that we actually get a performance benefit of that, we're going to have to pre-cache, a wide, because people will stick with their own original versioning model, right? We'll have to pre-cache 10 versions of Moment.js or something like that rather than just one. If assuming that there's 10 that are popular at any given time, right? We're not going to change.
Sorry, I also asked majority of the sessions. So there was set of privacy mitigations.
Sorry.
No problem. Is the plan create a set of allow lists that can be put in shared library with all these privacy mitigations, or like you're going to pick some of these? Sorry, it's probably already mentioned, but
The
so
idea would be,
yeah.
in my opinion, the most promising is that we lazily cache all of the popular libraries, whatever those are, because this means that anything that is a cache hit doesn't tell you whether it was automatically prefetched or fetched by visiting the site.
So when you say prefetch, they're just pre-populated somehow when things are okay. Yeah, okay. Sorry.
So a really interesting thing to me about that I didn't realize when Rob first mentioned this is it's 10 megabytes for the top 500. And I was like, but every time you push a Chrome release, you need to download 10 more megabytes. But that's totally not right. Every time the list changes, you need to download some small delta, and that list changes slowly. So it's like 10 megabytes for a year.
I think that was actually a question I've been meaning to ask, was like how quickly we'd expect this list to change, and kind of similar to the question, the concern about sort of picking winners in terms of popular frameworks, what effect this might have on incentives for sites to update their frameworks. Because I'm curious, in that sort of list of top 500, like how many copies of Moment, how many copies of Awesome, how many copies of jQuery is it?
Not that many, actually. I think I saw 6 or 7 copies of jQuery, and only 2 copies of Moment, but yeah. But the other thing I wanted to bring up is, hypothetically, if we add shared channel, we can also tell what is a release track of a library, and so we could consider giving a bit of a boost to like a new version of a popular library.
So have you looked like longitudinally in the HTTP archive to see, like, I don't know, 6 months ago, what were the popular lists of resources, and like 9 months ago, what were they? Because this could pretty easily, I think, answer this question of like, okay, if we, I don't know, load these lazily into Chrome, are we going to be changing them at like a month cadence, 2 months cadence, a year cadence, something like that?
I have not, but that's a good suggestion.
I was going to add one thing. I'm one of the maintainers of the Google JavaScript library CDN, and I think one of the main learnings I'd add here, I think is relevant, is that whatever the policy is for popular, it should be extremely clear, because at the JavaScript library CDN, everyone is like, well, I wrote a library, and I'd love it to be on that CDN. We're like, okay, cool. So having extremely like clear and quantitative things that like has benefit for incumbents, but also allows for the newcomers, all that. I think that'd be really beneficial. And I think also echoing one thing that Riley was saying around yeah, the incentives for like version bumps for a library. Current model for like how you handle your JavaScript dependencies is, you have a certain version, and then like maybe security bot comes along, tells you that there's a vulnerability. You're like, oh, okay, I can bump the patch version up. So that's pretty straightforward enough. But in this case, it's because it's tied so clearly to a shared cache thing, you may be disincentivized as a user to bump up. You also, the library authors may want to hold back releasing because of the shared cache benefit. So that's a hard problem. But
Yeah.
What criteria does the Google
whatever we feel like. Roughly, we don't have a good. Yeah, no, yeah. I'm just saying that policy is not the right one. That's it.
So there's some discussions that like we might be picking winners of the popular libraries, but I'm also kind of concerned about like the set of users who could be benefited from this versus not. For example, like we might be like giving more benefit to the particular set of users. For example, like people living in US, or like people who are currently heavily using web, but might be putting more penalties for the like regions who are ramping up on web usage, or like users who are not currently heavily using web. So for CDN, I think there's some like a regional, so some resources that are popular in some regions like tend to be cached in closer cache. I don't know much about CDNs, but this doesn't give that part, right? So what's your thought about it?
I mean, the thing that we need to guarantee is that when you get a cache hit against this list, you don't know whether it was pre-populated or not. And so maybe we could do something that's a bit regional, because you can already tell the region the user's in. Like, I'm open to suggestions for alternative ideas here, but
one way I think might be cool to manage it is to have do a cap on transfer as a fraction of the user's transfer, right? Say 0.1% of the data transferred will apply to this, and then you can just go from the beginning, right? So somebody that's not using their device very much, they might only get the top 4 popular libraries, but somebody that is using their device all the time, then you can hopefully try to, the proportion of benefit should be in proportion to the cost. And then that might also alleviate some of Paul's concerns. Instead of having this yes/no list, it's like, well, Google maintains a rank,
yeah,
and people who use their phone more get more things pre-cached.
Well, and a more powerful phone might choose to like store more because it has the space or something like that.
So the difficulty with those sorts of things, though, is now you lose predictability pretty dramatically.
But it's so the presence of the resources just tells you how the performance characteristics of the user's phone, right? Or
I mean, specifically, if I'm a web developer and do I cache Moment.js into my bundle or not?
Right.
I have to make a decision at build time.
Right.
What do I do?
Yeah. So this actually is my point too, and like just to underscore it, like, can we get a promise that like all of the browsers will drop this at exactly the same time? Because if not, then like, I don't know, am I going to make my site super duper fast for Chrome maybe, but it's going to just suck everywhere else? And then do they all have the same bundles, right? Like, how do I know? How can I reason about this? So like the more kind of permutations and things that we throw in for developers to reason about, the more harder it is to predict. And I think that is actually one of the reasons why we have the current state of things today, basically, because I mean, it's not that hard that we could say, like, we had the jQuery CDN, right? Like, there was a jQuery CDN. It was the official jQuery CDN, and like, what was the cache hit rate? It was not very high.
jQuery was actually one of the ones I found at many different URLs. So people are self-hosting jQuery.
But that's my point. Like, there was an official jQuery CDN, and there was a canonical URL you could point to. And yet we have also it on every other CDN and also local hosts and bundled in people's bundles. And I think
there's reasons
looking
to
at
self-host.
looking at the state of why we're in the situation today might be informative.
One of my concerns with the choosing winners is that we would want this to be a small package. And one of the possible advantages to this is like, the Unity engine or like a giant ML model that's 200 megabytes, and you would not want to push that to everyone, right? And so then we lose that huge benefit, possible benefit.
So we are like way over time. We should probably wrap up, but this has been an interesting discussion. I really hope that we can do something incremental and learn more about this. Thanks for coming.